So I'm Chris Ortman, and I work here at the University of Iowa programming. And we are going to talk about Docker tonight. I'm not a DevOps person. I'm not in the trenches doing real DevOps stuff. So my interest in Docker came based out of need. Like, I had some particular needs that Docker seemed to solve very well, and that was what got me to start investigating it. Those needs kind of started about 10 years ago, where the team I was on, I was the maintain the build server, maintain the issue tracking server, maintain the source control, kind of all of the different servers and components that we were using to ship our software in an agile way, right? And at the time, that was cruisecontrol.net. That was Track for issue management. Cruisecontrol.net was a continuous integration server. It was kind of based off of Cruise Control, which was Java. It was kind of one of the first ones at the time. Track for issue tracking, and Subversion for source control.
Oh, yeah.
A long time ago.
I remember that.
And we were on Windows, right? So we were mostly on Windows, and that meant that I had to install both Apache and IIS kind of on the same server, because Subversion needed Apache and some of these other systems, or cruisecontrol.net needed IIS. So there was this whole bunch. I spent probably a week just trying to get all of these systems set up and configured and working together. And then when you get done with it, you're like, don't touch it. Nobody go near this. It works now. We're never upgrading. We're never touching this again, right? And if I'd had something like Docker back then, my life would have been very easy. So things that make Docker awesome, right, is that I can install and run any application with a single command, okay? It's like having Git, which is a great source control system, but for servers. So imagine the power of what you're able to do with your source code, but to your server also. We always have written setup documentation for this is how you configure this server, right? Well, having your setup documentation become executable means it's never out of date and it always works. And isolation, which is really kind of the big thing for me, where Docker gives me very inexpensive isolation. I'm able to completely isolate Jira or Subversion or whatever application it is from all the other stuff on there. Okay? So, okay. So there's a few key components here. And I screwed that up. Alright. So first key component is called the registry, right? The registry is a place where I can go and get things from Docker. It's my catalog. Okay?
Your personal one or like a Docker repository?
Both.
Okay.
From registries, I pull images, okay? And we'll kind of go into each of these in a little bit more detail. I'm going to give you kind of like a table of contents of it and then go forward. So from a registry, I pull an image, which is my template, my system. I run an image, and now I have a container. And that's kind of like my virtual machine in a way, right? I can make changes to a container, and I can commit those changes and get a new image. Okay? And if I want to script how an image is created, I can use a Docker file. Okay? So I can build an image from a Docker file. And so our main things here are registry, container, Docker file, and image. All right?
When you say commit, is that like kind of the same concept as a git commit?
Yes. So that was my...
That was your then slide.
Yeah, that was my then. And yeah, cruisecontrol.net, giant XML configuration file that was awful to maintain. It was totally characteristic of 2002 or 3 or 4, whatever it was. So, registry, that's my storage location. An example of a registry that's public is Docker Hub. Docker Hub is like GitHub, but for Docker images, okay? So, you can use Docker Hubs if you want. You can use the Docker Hub registry if you want. You can set up your own also. Docker publishes a Docker container that is the Docker image registry basically. So you can just spin up a Docker container and here's your own private registry, right? So let's take a look at our first demo. Can you guys see that? You need bigger font.
A little bit.
A little bit, all right.
Or you just all move closer.
Oh, that's great.
Okay, let's try this. So to do this demo, because I don't want to make you guys watch me type, I'm just going to explain how this works, right? So I'm in a Tmux window. I've got two splits here. On the top is Vim. I've just got it open with some shell scripts of commands. When I hit a key on here, it's going to send what's on that line down into my terminal below it and run that command. Okay, so you'll just see commands magically start running. But that's what's happening. There's a thing called Vim Slime. Lets me do that. Alright, so remember I kind of said my example started with trying to set up and maintain these different build servers and configuration stuff, right? So if I had Docker, right, what I would do is I would search for an image for the thing that I want, right? So I'm going to modernize it a little bit because there's not images for TeamCity or not TeamCity, but for these old things, right? So I'm going to say Jira as my issue tracker now, right? So I can do a search for Jira, and it comes back with results, and I can pick one of these. There's also a Docker Hub website. Which basically the same thing, so you can come on here and search for it. There we go. So kind of like looking for an open source library on GitHub, right? See which one's getting downloaded the most, and you can go in and look at it and see what's in there. And this one's got a lot of stars and it's been pulled 44,000 times. It's probably a good one to go with. So let's see. We're gonna pick that Captain Action Hey. So I'm gonna Docker run that Jira image. Okay. That's it. All right. So the download has happened, right? Like the very first time I do this, Docker has to download some stuff. It has to download the image, right? That's done, and now it's up and going. Okay. So there's Jira. I want a continuous integration server. So I'm going to do the same thing for TeamCity. And just for fun, since at the University of Iowa we do a lot of Drupal, I threw in a Drupal example. And we'll open up our web browser. So what I'm doing here is, I started 3 Docker containers, right, based on these different images, right? I mounted them at specific ports, and so now I'm opening Firefox and browsing to my Docker host IP address at those ports. And so here's Jira, it's ready to go. Here is TeamCity, and here's Drupal. That's it, it's done. So
That's pretty awesome.
yeah. So I mean that's huge, right? And I've lived through the release nightmares of shipping a product where, all right, we've got to everyone come in for this Friday night install because we've got to get our servers set up and configured, right? And, how nice would it be to just say here, right? I mean, it's kind of like we used to make switches, like kind of a switch type device, right? And when we would set this thing up, there was the gold master CD, right? And that's your image. It's golden master. It's always going to work. So that's it. Okay. So to get these things set up, Docker can run on Linux, Mac, and Windows. Okay. Because of the way Docker works underneath, it does not run natively on Mac. It will run natively on Windows at some point in the future. But that's coming. So in order right now today to work on Windows and Mac, you have to have Docker host running in a virtual machine. Okay, so what I have, what you see here, I have VirtualBox running a Docker host virtual machine that my Docker client running on my Mac is communicating with, okay? And works the same on Windows right now. On Windows, easiest way to set it up and install it is with Chocolatey. On Mac, there's a thing called Docker Toolbox that you can download and comes with all the pre-built stuff, or you can install via Homebrew, okay? So, to kind of break down what this command is doing here, right? So this was the docker run command that I typed in to get Jira going. So run says, go find the image, cpt action hank at last in Jira, and if I don't have it already, download it from whatever hub I have configured, okay? And it searches the default Docker hub by default, and you can add others. So run says, go get that image, download all the layers for it, and then spin up a container. And when you do that, map port 8080, the host, to port 8080 of the container, right? So that way, you know, I can have all my containers set up and I don't have to go and mess with the ports in there. I can have 5 web application containers all running on port 80 in my default, right? And then just map them to specific ports on my image. It's nice isolation there. So, the image, right? The image is like a read-only template that has your operating system files in it, okay? And you can create new images by committing changes to a container or with a Docker file. Okay. I don't have the Ubuntu, so you get to see it download quick. So the image, every commit makes a new layer, right? So, and you see the SHAs there. So when Sindhu's asked if making a commit is like actually making a git commit, it really is, because what it does is it takes all the file changes in that layer, in that commit, generates a SHA for them, and then there you go. And so it knows if I already have this SHA, I don't need to rebuild it or re-download it again, right? So I'm going to do this. I've got it going, but I'm going to start it up again. So that's it, right? Like if you've worked with virtual machines in the past, right? I spun up that Ubuntu machine in less time than I could even go find VMware or Parallels, right? I mean, it's really, really fast. So that's one of the nice things, especially when you're, deving on this stuff, you don't want to wait. One of the first things that I kind of did is I had to make a bunch of changes to I had to make several of the same changes to our servers, right? And so I wanted to script them, but I wanted an environment that I could test my scripts in before I actually went and run them, right? So I created a Docker image that looked like our production servers, and then I could put my scripts on there, run them, check the results, and then, when I would get it wrong, I could just stop the container, change my scripts, restart up the container, and run my scripts again. It was very fast, right? If I was going to do that with normal virtual machines, snapshotting and restoring is not nearly that quick. So if I want, I can, so I'm in Ubuntu, right? And I did echo hello home or hello world into foo.txt, right? And so those changes are in that file. I'm going to exit, and I'm going to run that same one again, and it's not there. So I didn't commit anything. So each time I do a Docker run, I get a brand new container based on that image. The changes don't live between runs unless you persist them. So we'll make the same change again.
If you persist them, can you go back?
Yes. So I did a Docker PS, which shows me my running containers. Okay? So it gives them names. So there's Team City, Jira, and where is, oh yeah. But I don't see my Ubuntu one that I just had, right? And that's because I stopped it. When I exit, it stops. But if I do ps-l, it's going to give me the SHA-1 of the last container. That's what that -l is. Okay? And I can also do docker ps-a, and it'll show me all of the containers, whether they're running or not. But what I want is the SHA of that last Ubuntu where I echoed hello world into a file, okay? So I've got my SHA for that. Oh yeah, LQ just gives me the SHA. The L gives me some of the other information about it. And if I want, I can actually diff changes based on that SHA, right? So there's that same command docker ps lq, and then I passed it to diff, so the commands are composable, right? And I can see that I changed /home, I added home foo, I changed root, and I added bash history. Those were my changes. And when I want to commit it, I can say commit, I give it the author, I give it a commit message, I give it which SHA I want to commit, and then I tag it basically. Okay? And so now this time when I do my run, you'll see demo latest, right? Which is what I had on the as a tag in the previous command. So instead of Ubuntu latest, this is demo latest. And now when I cat, my changes are there. So images, right? They are built upon these layers, right? Every batch of changes is a new layer, and it's this one of the big new technologies, I mean, new as far as I know, in Docker is this thing called the union file system. And that's where it says, given all these layers of files, right, union them all together, and that's what the picture of your world looks like on the OS. Okay?
Can the application itself that's running inside the container do a commit? Like, so let's say you have Jira running, somebody creates or puts an image into it. You want to keep that image, so when you exit, it doesn't disappear. Could you have the application itself say, "Hey, commit this for me"? Or how would you hang on to that lost material?
There's another thing that we'll get to called data volumes.
Okay.
And so there's ways where we mount the physical storage from the host into the container. And so when you, like, if you upload an image, it goes straight to the file system on the host.
Okay.
So I can show that commit message if you wanted to see it. It's not viewing commit messages and some of the history in Docker is not a great experience yet. So, and honestly, like I've not had a need to do that in real life, because most of the time when I'm doing stuff like this, I'll do it from a Docker file. So I think kind of being able to just commit to images is one of those things that you do at the very beginning to get a base image, maybe with just a kernel or something like that, but in practice I'm not really ever doing that. So, the executable setup documentation, right? If you remember back to my cruisecontrol.net and track and all that, right? When I started doing that, right, I was trying to be very diligent, right? So I had the team wiki, I had the new wiki page, and I had these are the instructions for setting up this server, right? And the idea being that if the server goes down, I leave, someone else has to do this, we need another one, right? You should be able to take all those instructions on this wiki page and paste them into a shell on the other machine and get the same thing, right? Has anyone ever had that actually work for them the first time, right? I mean, by the time you ever end up going and redoing it, something has changed. Some version has been upgraded, some configuration file has been moved, there's, a name of the server has changed, it just doesn't work, right? So it's good, but not great. It has its problems. So being able to have the instructions that create your images that you use to run be executable solves that problem, because they'll always work. If you have the image, you built it from something, right? And so that's called the Docker file. You can kind of think of it as a make file for your image, okay? Yeah, and this is a quote that kind of related to that for me, right? That, it's verifiable. So one of the things that, and this was the thing that really, where I started on Docker, is we make Ruby on Rails applications here, and we have very, very good Cucumber test coverage. right? So we have lots and lots of Cucumber tests that exercise our application backwards and forwards. So that's good. Downside is that if I want to know if my change is going to break something, I have to make my change and then come back the next day to have an answer. Because there's so many tests and it's slow, it takes 8 hours to run all these Cucumber things. So that stinks. If I want to run these on my machine, I don't want to wait for that to happen. So then you need to have some sort of not browser flashing in front of your face while you're working, right? Like I want to just ship this off to run it on something else. So, there's a thing called XVFB, which emulates a display that will let Selenium talk to it, but that doesn't work on Mac. So what I wanted was like, give me a really lightweight virtual machine that I can get XVFB and Firefox and all these things configured on, and I can kick off my Cucumber run and actually go back to working instead of just watching it. So that was why I made a Docker image the first time. Okay, so this is the Docker file that I used to build that, and we're just going to kind of go through it and look at some of the commands in here. So every line is an instruction. Every instruction will be a commit. So from is the base image that I want to come from. So I'm going to start with Ubuntu 12. This could be CentOS or CoreOS or whatever, right? This is me. And then if you've done Ubuntu setup before, you recognize apt-get update and apt-get upgrade, right? I ran into an interesting problem once that we'll explain in this poop comment in a minute. So, like I said, right, every command is a commit. So why you see like all this apt-get all smashed into one, right, is because I don't want to make a commit per apt-get package. I want to run them all and then make a commit, because there is a small penalty as your number of layers increase. So I wanted that to all be one atomic thing. So what happened to me was I had made this image and everything was fine, and then I found that I needed to upgrade, I wanted to put a new version of Ruby, and I had to upgrade one of these packages, right? So I came and I added a package into this, and I went to do a rebuild, okay? Docker, when it's building, knows a SHA based on this command and can decide whether it needs to rerun this command or not, okay? So I changed a line here, and I went to do a build, and it failed. It said it couldn't find some package. I'm like, why? Why can't it find it? It used to work, right? Well, this line never changed, so it never did an update. So in the meantime, Ubuntu source package repositories had moved, right? And if I had done an update, it would have found out about that. But it didn't run this update command, so nothing worked. So all you have to do to make it rerun that command is change the line in some way by putting a comment called poop, because it will also do that. So that was to force that. And now I've since learned that what you really want to do is do apt-get update apt like this, and then it will always run the update. So yes.
Is there a way to be able to point it back to the original and say just rebuild everything without just like deleting every single hash and then rerunning this thing again?
It has to, so this command points to a SHA, and that, if that command changes, it doesn't know any SHA, so it can't, it has to be able to run the apt-get command.
But if you delete the SHA though, it should be able to rerun it. I'm wondering if there's a way to say, like, without deleting each SHA individually and then rerunning the script.
Yes.
Can you just say,
Yep, you can, Docker images, I think, I can see all of my layers, and I could remove them, and then have rebuilt it. That would have worked too. But wasn't like, that. I don't want to have to do that every time, so I'll find a different solution than that.
There's a flag to Docker build to rebuild the whole thing too.
Yeah, like dash force, I think.
Yeah, something.
Let's see, so more run, add, so I want to add something from a remote URL and stick it into a directory when I build, right? I can either, because this was going into Git, I wanted it to download from Mozilla versus I could just download the tarball and put it into my Git repo and have that work too. Export an environment variable, run a command, create a user. On build, so these give it instructions so that when someone else makes an image and uses this as the base, these instructions will run then. Okay. And when you look at, let's see here. It's not- I just want to kind of show you, right? So when you build your image from a Docker file, Docker will only use things that are in the folder where the Docker file is. Because what it's going to do, it's going to take everything in that directory that isn't excluded by your ignore file and send it to the Docker host for building. So that really trips people up a lot because, like, you know, I want to link it to my source code that's over here in this other directory and I want it to copy it into my image, right? Well, it doesn't work. You have to get your source code in some subfolder next to the Docker file, and then you can add it to your image with one of those commands in the Docker file. Okay? So, isolation, right? We're all, I think probably most all familiar with virtual machines, right? Which is virtualization at the hardware level, right? So if I start up a virtual machine and I go look at the system properties, I see that it has a CPU, right? And there's some settings window somewhere where I went in and said, this looks like a 2-core CPU and give it 2 gigs of RAM, right? And then when I go look at my virtual machine, I see 2 gigs of RAM and I see the 1-core CPU or whatever it is. And so that's hardware virtualization, right? There's a computer program software pretending to be a CPU and pretending to be memory, okay? Docker is operating system virtualization. So whereas with the virtual machine, I only see the 2 gigs of RAM that have been allocated to it. When I check how much RAM I have in Docker, I will see everything that's on the host, okay? And if I look at disk size, I actually see the disk size of the host. I can't reach it, but I see the disk size, not virtualized hardware, right? And that has a big performance benefit because not having that extra virtualization layer for, like, say I'm running, who was it, Joyent? Joyent was kind of one of the early goers into a lot of this stuff. And they saw 60% performance improvement with Postgres when they started running it in containers versus virtual machines. And they attributed that to the fact that they weren't virtualizing the hardware, right? So it's a lot more performant to be able to run in the bare metal. The other thing that, like, if you're a sysadmin person, right, and, you know, when we ask for a virtual machine, they'll give us a virtual machine and they'll give us 2 gigs of RAM because they don't know what we need, right? So some person is making a decision about how much RAM to allocate to this, where with Docker and containers, you can let the kernel decide how much RAM needs to be allocated to the various containers. And you can set limits that say don't let it go over this, but otherwise you can kind of leave the management of those resources up to the kernel. And for the most part, I think the kernel will do a better job than, you know, the guests. So to get all this isolation and make that happen, it uses namespaces, control groups, and that union file system, right? And the end result is that it looks and feels like it's my own little unique Unix box, right? But it's really not. It's really running on the bare metal hardware. There's no virtualization taking place. And that isolation, that's the thing that I really like. You know, this is a screenshot. You can kind of see where on the top, I am checking disk in my virtual machine, right? And then down below, let me see, what is this? I don't remember what is what. So I see 18, I have 18 and I can see 6. I have 19, I can see 6.
Looks like you're running it from 2 different containers, and the top one looks like it's from the actual thing.
Yeah. So I'm running it from, so Docker boot to Docker, that is the Docker host, okay?
That's your host computer.
Yeah. And I can see And that's virtualized, so I have a 200 or a 500 gig hard drive, but it only can see the 20 that's allocated to it, right? But in my 2 Docker containers, I can see the whole hard drive of the VM that it's running on.
So I was kind of curious, actually. One thing I always kind of struggle with when I'm reading about Docker is how it actually handled, like when you're saying I'm starting with a boot image of Ubuntu or something like that, is it basically mounting it like mostly like an ISO almost to a virtual part of the disk and then CH-rooting into it? Is that the general idea?
For the most part. So remember when I had said Windows and Mac can't run it natively, right? That's because of the kernel. So when you run, it's a shared kernel, and so it's not really Ubuntu. I'm using Ubuntu to set up the file system and everything, but once I run it in, let's say I push it up to Amazon and I have CoreOS. I have a CoreOS host in the Amazon, or a CentOS host in the Amazon, right? And I run my containers on there. I'm running on the CentOS kernel. So then it's a combination of trut and namespace and whatever to keep all those things isolated from all the other things on there.
If you're looking for a good example of something you can pull right out of the box with ready-made containers in it that you can play around with, FreeNAS uses containers for all the application plugins you can set up, and it's really like you just click on a feature that you want to install, and it asks you for an IP address and stuff like that. But then you look in the file system and you're like, oh, I can just navigate to that particular jail, and there's all my stuff, like it was like it wasn't running in a virtual machine. It took me a while to understand that myself.
Good. That's more than I know about it. One of the things I like about Docker is I do not know how a lot of these things really behave underneath it. Docker does a good job of maintaining it for me, so I can kind of, get work done, right? I'm not using it for mission critical production stuff. I'm using it to run test servers. One of the things that I like, that my next step that I want to do with it is I've got a DigitalOcean droplet, and I have my wife's got a couple WordPress blogs on there. I've got a WordPress instance, and I want to be able to run some of my kids' Minecraft server on there, right? I mean, just some basic stuff. So, but I don't like things that are not repeatable. And so I don't like the idea of me just going and setting stuff up on this server, and I hope that server doesn't die and I have to repeat this stuff, right? So I want to and that's the way the server is right now, and it bugs me. So I want to take this server and have it be Dockerized WordPress, Dockerized Minecraft server, Dockerized Nginx on the front end, right? Like, one of the kind of tenets of Docker is I want, think at the very beginning, right, when I said Docker run Jira, and it's good to go, right? I want that, like, that's a good container. I think that's like a good citizen. So if I have a WordPress container, I don't want it to be a container for Apache, and a container for PHP, and a container for MySQL. I want to be able to take the container and run it, okay? So in order to get that to where I want, right, I also know that, if you're going to, from what I've read, right, when I want to set up WordPress and I want to front it with Nginx, there's a lot of Nginx config that goes into that to make sure it bypasses PHP things like it should, right? So what I'm wanting is I want an Nginx on the front end that basically routes to different Docker containers. So it comes in on this URL, it'll proxy over to this port, basically, which is a Docker container running this WordPress. It comes in on this domain, it proxies over to this one, right? And so to do that, I want to create containers for a front-end Nginx, WordPress container, and MySQL container. And I can link those together with data volumes and everything to make them talk, but I still have to get all that stuff up into that DigitalOcean, and that's kind of where we're going to get to what Nathan can talk about, where, to get all this stuff still up there, right? Like, having containers is one thing, but I still got to get it on my servers, and that's kind of where I'm kind of waiting to learn about Chef so I can go home and do this, hopefully. So we're going to take a quick look at how, like, if I'm going to have a MySQL, right, I don't want the container to stop and the data to go away, right? So that was the same thing we were talking about before with the images. So to get around that, what we do is we mount a data volume in our container. And that looks like this. So what this actually is this is a data-only container. So I'm going to create a container that mounts this path, and anything that goes into this path will be written straight to the host disk. Okay? And then I'm going to load the volumes from this container into this second container. And so on this, when I run this, whenever I write to var lib MySQL, it will go straight to the host. Okay?
So is that -v, is that the volume container?
Yes. -v is volume container.
So anytime the application writes to that URL or that path, you tell it to go ahead and send it to the file system?
Yep.
If you wanted to, could you send that to any other arbitrary folder on the actual file system?
Yes.
Okay.
Think, and like you can mount. Let's see. So you can actually, even with the VirtualBox stuff going on, you can actually mount a folder from your Mac directly into your container,
Okay.
and it's kind of slow. So if you're doing a lot of writes, it won't work very well. But it's like -v:/tmp/foo, right? So that will mount the TMP foo directory from my host to that path
Okay.
in Docker. Okay? So, now that's the data volume containers. I think are pretty common practice, especially when it comes to database stuff.
So they just don't throw away what's in it when they shut down.
Right.
They kind of leave it there.
Right? Because
Yeah.
so because if I did this, right, and it writes into there, and a file goes on my Mac to temp foo, and the container stops, that file's still there, and I start the container up, and it mounts it, it's still there. So, and that can, my understanding is that simplifies backup strategies for people too, because it's all just in that one folder, and then you can back that up, and you can move the database server around from different physical machines fairly easily. So that's how it looks. So recap, right? We can download and run pre-configured applications. We can create images and share them. We can persist data. We can link containers together. If I do, so one of the other great things I found with this is, when I have a web server in the cloud that I'm hosting stuff on, right? And especially WordPress, and it's got a MySQL database there, and I need to do some database stuff to it, right? I don't want my MySQL ports hanging out over the web, so I want something that I can get on there with, which usually is something like PHPMyAdmin. But I also don't want that running all the time. I just need it for this one thing, right? So what I can do is I can have my MySQL container on there, and when I need PHPMyAdmin, I start up the Docker container for PHPMyAdmin, and I do what I need to do, and I just throw the container away, and I don't have to leave remnants of that on my server. Kind of helps for managing security. Thought I had there. So to see the link, right, there's an example of this right here. So if I have a MySQL container running, right, and now I'm going to spin up a PHPMyAdmin one, and when I say link MySQL DB to MySQL, what that does is it'll define a bunch of different environment variables in this container that give it ways to reference that other MySQL container. So if I have MySQL-DB:MySQL, that means there will be a MySQL_IP_address that's just defined in this container. And so anywhere I refer to that environment variable, it'll get the right values. Okay? So that's how the links work. And registry, that's the storage location. Image is the template. Docker file is the make file. And container is your virtualized OS. There's the picture one more time. Right? I pull images from a registry, I run them and get a container, I commit changes to a container, get an image, I build images from a Docker file, and then I can push those images back to a registry. That's Docker. Questions? Otherwise, and we can wait too and
trying to understand this, because my holy grail, I'm not day in, day out coding, but I'm always trying to create just quick prototypes of stuff. And my answer to that has always been a virtual machine, and it sounds like this might be even a little faster, cheaper than that now, because this is my starting point, a little bit different than like what I would have done with like something like Vagrant. You create the big Vagrant file, you create a virtual machine, you grab all the things with something like Chef or Puppet to configure it. But this is almost like you're saving a couple steps, right? You get it where you want to, you say save, or make the image, and then I can just use that from then on out.
Yep. And right, like every virtual machine has a copy of the operating system. And right, with Docker, right, every image that's built off of that Ubuntu 12.04 base is sharing the same copy of the operating system. So, you know, your VMs are much cheaper in terms of disk. Like
You're not running like 12, if you have 12 virtual, if you have a virtual, an application-specific virtual machine, you're running the kernel on top of that virtual machine, or the virtual machine is running on that kernel. Will, if you have 12 VMs, you have 12 kernels. This is one kernel because it's running off the
operating system.
Yeah, it's running off the native level.
Okay.
Is that one of the reasons CoreOS has been kind of a big appeal to Docker users? It's because it's super lightweight.
Right.
And just gives you that host environment.
Yeah, and it doesn't need any of the other stuff.
Yeah.
You know?
Because
And
it
I
can be
know-
picked up by the container.
Yep. And I know a real common complaint, like people are saying the Docker images are still too big. And there's people working on trying to like slim them down. You know, I don't know, I mean, so TeamCity is 1.3 gigs, that image is. CentOS base is 190 megs.
And doesn't it, like, if you have a previous SHA from an image that you're downloading, say you're downloading, like, the Atlas and Jira one, and it's based off Ubuntu
Yes.
14.04, and you have a Ubuntu 14.04, doesn't it just?
Yep, it's shared.
Yeah, that's,
And it downloads all the layers in parallel too, so the downloads are pretty quick when you.
Oh, it's in
pull it
parallel?
in.
Okay.
So, this is one thing I've never really explored, but I guess you're kind of hitting on it. Do you need to have the same base operating system to be running?
You don't
run?
have to.
Okay.
You'll save disk space if you do.
Okay.
Linux.
Yeah.
Like you have to have Linux, but you can run a Red Hat container on Ubuntu.
Okay. That's
So Docker is all about kernel compatibility.
okay.
So it's based almost entirely off of the ABI of the Linux kernel and what system calls you can do. So CentOS, Ubuntu, they're all doing the same system calls to the same kernel at the end of the day. So that's how the containers end up. They don't care what OS you're running on as long as they can do the system calls.
I'm curious as to how well that works when you translate it over to BSD or something like that.
It doesn't.
Oh, really?
it's system
That's
D.
why they're running everything in a VirtualBox VM that's running Linux.
Yeah,
that's
so it's
our-
like Linux containers.
So BSD has some jails, that's the layers. Well, BSD has jails,
Right.
and so they're making a backend for Docker that runs some jails, but
Okay.
your images won't be compatible with them. Yeah, and I guess when they do it for Windows, it'll be a similar thing. Yeah, Windows is attempting to do that.
And that's why right now you run the host until those are available.
Yeah, so like on OS X and Windows, you're spinning up a VirtualBox VM that's running Linux.
Okay.
And inside there, you're running your containers. So you're not actually running natively. If you're
But if you were
OS
running
X
it
or-
natively on Windows, you'd be running a Windows Docker, right?
Eventually.
So you wouldn't be running like Ubuntu on
Right.
the Windows kernel because that doesn't make sense.
Eventually, at some point, I
Well,
should
could you?
be able to have an IIS container.
Eventually, I think they're trying to build it in, so I think they're actually gonna allow Docker images that are run on Windows too. And Server 2016, I believe, is first.
So, but they'd be running Linux.
No, they'd be Docker images that are built for Windows.
I think, I don't
No,
know.
well, like he's saying, like running a Linux
I'd be surprised
image
if they
on
didn't have that.
Windows natively.
part of it.
Yeah, that won't happen.
That'll go through hypervisor.
So the Docker engine itself is abstracted away from the actual container runtime. So they're trying to use like the Docker interface of like Docker run and all that cool stuff.
Yeah, but they have something in the Windows kernel that they're doing
Right.
to
Docker in, so you can do the same type of stuff, but it's not magically going to be Linux.
Right, so you'll have Windows-specific images that work on the Windows kernel.
I could have a Winamp container.
Throwback.
Wow. Cool. So, all right. So it seems like we got some people here that, a few people here have some Docker experience, and then some people are new. It seems like it's pretty good split. It seems like.
Did you have a question, Howard?
So has all this stuff been busted into yet? Or is it pretty tight?
You know, I think Docker some other people feel free to jump in. I think like Docker by default wants you to talk to a local socket. It's not meant to be on the network. So I think under those requirements, I think the isolation and all that stuff is fairly well vetted. I don't know of any major leaks.
Just as a like Telefarm is running. Well, we have a pass provider that their whole business is running Docker containers, and their environment is HIPAA compliant, which has lots of security standards they have to meet. And so
No, it doesn't really have that many security standards.
oh well, it's okay. So you would be able to speak to him more than I would.
Hey, basically HIPAA just basically says, oh, you need to have isolation, but and then somebody else looks through the manual and highlights where it says isolation and says we're compliant. that's security in HIPAA. I will say this for what it's worth. For my read on containers is a lot like sandboxing. Yeah, it's secure as long as you have locked down what's inside the container. Because at the end of the day, still the virtual machines, ESXi, VMware, and there are now threats in the wild that they're talking about that can go from the VM to the hypervisor and start wreaking havoc on the other machines. So, and everywhere is pretty insecure at this point, or it's.
All right, great.
You're only as good as your underlying OS is really what it comes down to.
I guess my question, that's always true of everything probably. Everybody in this room has probably done this long enough to know that. But I guess the question is like, are there situations where you're playing around with your WordPress thing where you like fat finger something and totally blow your foot off? Like is the how you do stuff, daily how you do stuff, prevent you or at least guide you in a direction that you're not going to do that stuff. Whereas in your configuration, I set up track and subversion and Apache whatever and all of that sort of crap too. Like it was extremely easy to essentially just like leave yourself hanging naked somewhere. I mean, do you put yourself in that position doing this stuff?
So like
Is that a
reproducibility versus security?
I mean, from a brand new to Docker person, I would say that I feel more comfortable doing it that way, just because you have a Docker file that says this is what I did. Because the alternative is you run and you did a setup at some point in time, and then you had to remember all the commands you did, and if you didn't paste them into like a doc or something, you have no clue what you did. So just from that perspective, I feel better that way, because I'm like, oh, well, I did miss something, because clearly it's not in this file.
Yeah, and you can always blow the container away and start over.
I would imagine to some degree, because you're running with these containers, there is some additional level of scrutiny you can have against what's going on in them, as opposed to like a VM where logically, or to some degree, you're kind of you still want it being in a black box because of the abstraction layer. This actually provides a little more traceability as far as the activity goes.
But I did read an article where they did a survey of images on the public Docker Hub, and there were a lot of publicly available images that had a lot of unpatched vulnerabilities, because you build this thing and then push it up there, and then somebody downloads it and says, "Ha, I'm using Redis, it's so easy," and then, and then doesn't realize that they just downloaded an untrusted binary off the internet, and they're running it, and you know it's their responsibility to keep it up to date, keep it patched, and so you know it's very convenient, but you need to also know that you know you're running software off the internet.
Is that a good transition to what you're going to talk about?
Sure.
Is that a preview?
Yeah.